So go ahead and get out your notes. Okay, if you've been checking your grades, you see that I updated them this morning with the current grades. You'll see that all the assignments from last quarter have disappeared. They're in my permanent grade book. The grades you see are just the ones, papers you've turned in this quarter, but the grade you see is the average of the 2 quarters, assuming I think it's 14% from this quarter and 86% from the other quarter. And then as we go through it, it'll eventually turn to 50-50. So every day I change those percentages, so this quarter counts more and more of your grade because you've done more and more of this quarter. Does that make sense? So it's really, I'm trying to report. If somebody asked me today what grade you were going to get in class, I could tell them it's going to be that grade because it's this much of this quarter and this much of that. Okay. All right, so today we need to talk about atomic orbitals. And there's some patterns of these atomic orbitals, but what we're talking about is places where you can find electrons. Okay, remember, the electron cloud was a place where you could find all the electrons. Atomic orbitals are where you're going to find specific electrons. Okay? So it's kind of like a hotel. The hotel is where you're going to find all the guests. The room is where you're going to find specific guests. Does that make sense? So that's the analogy. Okay, now there's 4 kinds of orbitals. We're going to learn their shapes, how many they can hold, and what energy level they start on. So the first is called the S orbital. Okay, and there's an S orbital in every energy level. So there's an S orbital in the first energy level, there's an S orbital in the second energy level, there's an S orbital in the third energy level. Or there's an S orbital that is 1 wave, there's an S orbital that is 2 waves, there's an S orbital that is 3 waves. Because remember, energy levels are waves. We changed that definition. Okay? So, and this would be the difference between the waves. 1s would be the smallest, the first energy level's S orbital would be small. Second one would be bigger, second energy's S orbital. Third energy level's S orbital would be bigger still. What do you think would be true of the fourth energy level's S orbital? Even bigger, but they're all the same shape, they're just different sizes, and they're all spherical. All little spheres. Now, you'd think that S stood for sphere, because it would make sense, but it doesn't. S stands for sharp, which is the exact opposite of a sphere, because the S comes from the lines on the spectrum. That if you look, there are patterns to the spectrum, and there was a series of lines they called sharp. These are sharp lines. Turns out the S orbitals draw those sharp lines. So the orbitals get their names after the lines on the spectra. So they're still connecting atoms and light. Okay? And an S orbital is a room for up to 2 electrons, just like a hotel room is a room for up to 2 guests. And you can have empty hotel rooms, and you can have full hotel rooms, and you can have half-full hotel rooms. So the S orbital, there's a chance you can find 2 electrons in this sphere-shaped region. That's what we're saying. Okay? Now we are too lazy to say the first energy level's S orbital and the second energy level's S orbital. That's a lot to write and say. So we shorten it and we call it 1s, 2s, 3s. So the number in front is the energy level, the S is the shape, the type of orbital. Okay. The second group of orbitals are called p orbitals. Okay? There are no p orbitals on the first energy level. They start on the second energy level, and there's a p orbital every level after that. So there's a p orbital on the second energy level, there's a p orbital on the third energy level, there's a p orbital on the 17th energy level. Now, it depends on who you talk to, because there's the picture of what they look like. Some people call this 3 different directions, some people call it 3 different shapes. But it's the same shape in 3 directions, so you could look at it either way. But there are 3 of them. There's one along the x-axis. That one's actually called px, p sub x. There's one along the y-axis, p sub y. And there's one along the z-axis, p sub z. Okay? And the dumbbell, they're talking like the hand weights, where they're narrow in the middle and wide on the ends. That's what the book uses as an analogy. Okay? Key is they're wide out here, narrow in the middle. Okay? And each one of these shapes can hold up to 2 electrons. So there's room for 2 electrons here, 2 electrons here, and 2 electrons here. So in the p orbitals, I can hold a total of 6 electrons. See where I got 6 from? 2, 2, and 2. So in 2p, there's room for 6 electrons. 2 in this one, 2 in that one, 2 in that one. Make sense? Now, really all 3 of them there at the same time, right? And not only that, not only are all 3 there at the same time, I'm not going to have those without having s orbitals too. So if this is 2p, there would be a 1s orbital inside, and then there'd be another s outside. So that would be the specifics where you're going to find the electrons, and the whole piece would be the electron clouds. So you put together atomic orbitals to build an electron cloud. So electron clouds where all the electrons are, orbitals is where specific electrons are. Okay. The next set is called the d orbitals. Okay. The d orbitals start at the 3rd energy level. So there's no d orbital in the 1st energy level. There's no d orbital on the 2nd energy level. There's a d on the 3rd, 4th, 5th, 6th, 7th, all the way up. They say they have 5 different shapes. Really, it's 4 different directions and 1 different shape. Does that look like clover leaves in 3D? Well, 3 of them do. The 4th one looks like a barbell with a donut around it. You actually have to remember the D shapes to get kind of complex. But each one of these shapes can hold up to 2 electrons. Okay, now we said that these were orbitals come out of an equation for a wave. Right? It's all about Schrodinger's equation for the wave. And waves are going to be repetitive. So there should be a pattern to these orbitals. So the next type is called an F orbital. And if you look at the other 3 we've done, you should be able to write the next few lines. You said there was an s orbital in every energy level. P didn't start till the 2nd energy level. D didn't start until the 3rd energy level. What do you think is going to be true about F? Doesn't start until you get to the 4th energy level. Okay, let's try the pattern for the next line. S had one shape, just a sphere. P had three shapes. D had five shapes. How many shapes do you expect for F? Isn't that odd? Yeah. It's also prime, but it's seven because it's seven different shapes. Now, I didn't draw them all here. I drew the donut ones because donuts. What's the next line going to say? Each holds 2 electrons. So there's a room for a total of 14 electrons. Okay, so there's the 3 of the shapes that look like p orbitals with a donut on each end. Okay, and here's the other 4. They look like jacks. Okay, let's see if I can show you 2 of them in 3D. Come on, Mr. Orbitron. Open up the wrong browser. Gotta live on the edge. Well, that is Edge. Now Edge won't place this. Huh. Died on me. Oh well. Okay. Let's try it this way. Come on. Okay. So there's a 1s. Notice it's a sphere. And here's a 2p. See, it's a barbell. That's px, py, and pz are the same thing, only different direction. Fact is, I could put 2py, 2px, and 2pz. All in the same one, and they just overlap each other. Okay. Let's get rid of these. Okay. 3D. Let's see 3D and 3D. Oops, the wrong place. So 3D. Okay. Somewhere in there is a place for up to 2 electrons. Okay. And we only go to 4. There are no Fs? Oh, they don't do the Fs. Oh well. Okay. So those are the shapes we're talking about. They're really 3-dimensional. Okay. So, important things you should have taken out of this. So, in summary of what we just talked about. Okay. We got the 4 orbitals, the S, the P, the D, and the F. The number of shapes will tell you the maximum number of electrons. And you need to know when they start, what energy level they start at. So, how many shapes of s orbitals are there? Well, S was the sphere, right? So there's only one shape. So what's the maximum number of electrons that you can put in an s orbital? There's 2. And what energy level do the s orbitals at the first energy level? Yeah. Okay. And the number of shapes for p orbitals? 3. The maximum number of electrons? Well, there's 2 per shape, so that gives us 6, right? And they start at energy level number 2. Hey, number of shapes for Ds? There would be 5. The maximum number of electrons? 10. And energy level number 3. And Fs, 7 shapes, 14 electrons, energy level number 4. Now, we stop at F because we'll find that we don't need to go beyond it, but there are orbitals beyond F. The next one is called G. What do you think that's going to be true of the G orbitals? There would be 9 shapes, right? With a maximum number of 18 electrons. And start at energy level number 5. Now, for most of you, those letters and numbers shouldn't be just bizarre things. Should help make something make a little bit more sense. And that is the thing above my head. Been sitting there all year. Did you see S, P, D, and F? Notice I've got the 1 for S, and then 2 has both S's and P's, and 3 had S's, P's, and D's. 4 has S's, P's, D's, and F's. Okay. So, what's the maximum number of electrons that can fit into a p orbital? Well, how many shapes is P? 3, so that makes a total of 6 electrons. If it's got less than 6, it's not full. If it's got 3, it's half full. Make sense? So what's the maximum number of electrons that can fit in the 3rd energy level? So what kind of orbitals do I have in the 3rd energy level? Do I have S's in the 3rd energy level? Yeah, they start at 1 and it's in every energy level after that. Do I have P's in the 3rd energy level? Do I have D's in the 3rd energy level? Do I have F's in the 3rd energy level? No. So what I'm in effect what I'm asking is what's the maximum number of electrons you can put in an S, a P, a D, and an F? And that would be 2, 6, 10, and that's 18. Everybody see how I can fit at the 18? I got 3 types of orbitals. Each one holds that much. So that's where they go. Okay? That's where they go. That's how you build an electron cloud. But what order do they go in? Okay. Okay, what gets slightly confusing here is that energy and energy level are different things now. Energy level used to be rings for Bohr. But we said no, the first energy level is 1 whole wave. The second energy level is 2 whole waves. The third energy level is 3 whole waves. That we've changed it to waves. Okay? So an energy level is not about a ring anymore, at least not in quantum mechanics. In fact, we'll actually talk about it in rings later because it simplifies some of the things we have to do, but we know they're not really in rings. Okay? But energy levels are really about waves. So when we say that they fill lowest energy first. But lowest energy is not always lowest energy level. Lowest energy is not always lowest wave. The way I think about this rule is you can't fill a bucket from the top down. Right? You got to fill from the bottom up. You got to raise the energy of that water. You can't put it, the top can't be in the top because it's got too much energy. It's going to fall to the bottom. Okay. The problem is the energy levels overlap. That part of the fourth energy level has less energy than part of the third energy level. So that the third energy level can be above the fourth energy level. It can take more energy to make 3 waves than to make 4, is what we're saying. So they do not fill up in order of energy level. They fill up in order of energy. So one of the key tasks we're going to have to do if we're going to describe where all the electrons are is to fill up the atom from the bottom up and see where they go. So we need a way of counting how many electrons we have. So our counting system relies on boxes. And you're going to draw a box for every shape of that orbital. So an S gets 1 box. P's get 3 boxes. D's get 5 boxes. And F's get 7 boxes. Because S's have 1 shape, P's have 3, D's have 5, and F's have 7. Each box is room for 2 electrons. So this is just bookkeeping. That's all we're doing, just doing some bookkeeping to figure out where they're at. And then we draw the waves all over each other. Ooh, it's scary to think about it that way, but that's really what it is. So, we're okay with the system? Now, for hydrogen, this is what it looks like. That the 1s, the 2s, the 3s, the 4s, the 5s, the 6s, and the 7s are all even with each other. And that works for hydrogen because one of the complications is that if I put an electron in and then I put the second electron is going to push away the first one. And math gets more complicated. And when they start pushing on each other, these orbitals that lay on top of each other are going to push on each other. And it changes the order that they fill up. So that if you follow it up, first you fill up 1s, then 2s, then 2p, everything's going good. 3s, everything's going good. 3p, everything's going good. But 4s